Man, the waves are just... Hey, Mr. Wara, come on. Get serious. You're not on your beach. This isn't La Jolla Shores. Come on, my friend. It's time to get into math. I know, that's why you joined me today, right? It's like, Mr. Wara, we have been waiting patiently for the new math video. And here it is. Amazing with this centipede. Yes, centipedes. Oh, it's the feature insect of the week, I guess. Those are pretty gruesome guys. Pretty vicious insects, I'll have to say. Run into a few of those in my lifetime. Let's go ahead and look at our learning target. We need to focus. It's math time. You know, that math kind of thing. Anyway, well, welcome aboard, you guys. I'm glad you decided to join me after all. Here we go. Learning target. It is our objective. It's our purpose. It's what we live for. That's right. We're going to round a given decimal to any place using place value understanding in a vertical number line. Oh, yes, I remember this learning target. Very, very confusing. Yes, I would say so myself. And we are going to actually do this video based on the Eureka lessons. This is Module 1, Lesson 8. So let's go ahead and get started here. Okay. So the first thing we need to do here is we got to say, why are there so many centipedes on my paper? Oh my goodness. They're just like tripling and quadrupling and oh my goodness. Okay, that's all right. You add a little decor, I guess, to the page, the slide. Let's look here. It says we have to round 49 and 67 hundredths to the nearest 10. Purple sounds good to me with a purple background. Yeah. So the way we were doing before, the first thing that we did, if you recall, I know you have a good recollection, is you recall that we did, yes, we put in our decimal point, but it's very, very important in math. I mean, decimals are new, really new, I think, for this year to the extent of how we're learning them. I mean, fourth grade, I mean, come on, that's baby math compared to what we're doing now. I mean, this is some pretty powerful stuff here. So, but one concept is so important that I can't emphasize enough is the fact that any digit that you find or any place value, the right of this decimal point, it becomes less than that one whole. Like when we count things and we say 1, 2, 3, you know, it's less than that. It's like when we start taking fractions and pieces of things. Whereas when you head this way, of course, you end up with whole numbers. Okay? Just thought I'd make that point. So let's go ahead and do what we did the last time, and by putting the 4 in the tens place there, then the 9, and then we can put our 6, 7. Looks like we don't need anything here in the thousands place. However, you could put a 0 here. There's nothing wrong with doing that. Perfectly legal. You know, the math patrol are not going to come out and give you a ticket. Okay, at least I've never received one myself. No, because it's an equivalent decimal. That's what that's called. It's an equivalent, which means it's the same. So you could read this as 670 thousandths, or if you didn't have the 0 there, you could read it as 67 hundredths. It would mean exactly the same. All right. Now, what are this part? Now, this is where it starts to get a little tricky. You see, we have to take this number now, we're going to take this number now and we're going to go ahead and rename it. Now, by renaming it means that we're going to, rather than represent this number in standard form, this is considered standard form, what we could do is we could say, let's do some regrouping here. Rather than saying that there's 49 wholes, let's go ahead and see how many tenths that would be if we wanted to just put everything in tenths. Okay, we could do that. We know there's 10 tenths in one whole. So if there's 10 tenths in one whole, if I have 49 wholes, you can see by that tenths that 1 0 suddenly makes this 490. Now, it makes it 490, but we also have the 6 tenths here. So we could, similar units, we could actually put the 6 there. Now we have 496 tenths. It's the same thing as 49.6. Exactly the same thing. In fact, what's happened, if you look at this, and where this could be confusing for some, is that what we've actually done is we've multiplied this number by a power of 10. See, you can hardly see my little arrow there, eh? There, a little bit better. There you go. We've multiplied this number by a power of 10, therefore changing it into 496. Now we still have our 7, and we just put that there. Now for a lot of you, and I'm going to be honest with you, this is a little confusing in that we're renaming this number in tenths. Okay, I'm okay with that. And the 7 we have to leave there because the 7 can't be renamed as a tenth because we don't have enough of them. We only have 700ths. And if you recall, and this is what's really important though, you do understand, is that there are 10 hundredths in every tenth because this is all about the power of 10. So that would mean that I would need 3 more hundredths so that I could add on and put a 1 in here. All right? And this, I can see where it'd be confusing for some. Now we can go ahead and take this and we can rename this number again, but as hundredths. Well, here we multiplied by 10. Well, here we could just multiply by 100. Hence the theme of the centipede. Yeah, centi means 100. What, do you think I put that centipede on our screen by accident? No. No, actually, the centipede completely, it was the invasion of the centipedes. Okay, I didn't really have anything to do with it. So if we multiply that by 100 then, now we're bringing over 6, we're going all the way across. Interesting, because there are 100 hundredths in one whole. 100 of them. That would mean then, just in 9 ones alone, we're going to have 900. Okay, because we have 9 and you have 100. 9 times 100 is 900. So we actually would end up having 4,000 because we're going way over 4,900, right? And here we have 6 tenths. Remember we said that there were 10 hundredths in 1/10. So 6 times 10 is 60. And finally, we have our 700ths that we could add on the end. So we end up with 4,967 hundredths. And it's kind of confusing. When we think of place value in numbers, this doesn't seem to make a lot of sense other than trying to improve our understanding of place value. But let's go with this, okay? I'm just expressing my opinion that I think this is a little on the confusing side. Because now it's asking us to round this number. Okay, here we're going to round it to the nearest 10. All right, I'm just putting those there for the time being. I could have just looked at this. So if I round number to the nearest 10, well, when I look at this number, I see 4 tens, and then I see 9 ones. And then I see this. Which one of these, the way this number was decomposed, because that's what we did, we decomposed this number, would be the best way to find it to the nearest 10. Well, it surely wouldn't be this, right? This is way too confusing here. But since tens are up here, it would make sense that this number here, right up above, would be the best way, right? And when we look at tens, we're thinking A, the minimum, and like the maximum. I'm going to start using these two words because it makes sense to me. Maybe it'll make sense to you. Because the 4, its minimum is going to be 4. When we round the tens place, he's either going to remain a 4 because he can't go down to a 3. Okay, he's at least a 4. But how high could he get? And he could get up all the way to a 5. So minimum and maximum. So we could think of this down here then, if we were to do this on our little vertical line, that 4 tens, right, is equal to 40. And that the maximum, we said it could be 5. So that would be 5 tens, which is equal to 50. All right? Seems simple enough, doesn't it? And then finding that midpoint becomes important when we want to decide, are we going to round it here at 40, or are we going to round it here at 50? Well, that midpoint puts you right in the middle. So if you have 40 and 50, you have 45. Fair enough. Our number is actually 49. Okay, we have all this stuff here at the end there, but we're not concerned with that at all. And we're not concerned with it because we're not rounding to any of these place values. We're rounding to the tens. And the only place value, the only digit that matters when we're rounding something is that digit to the right. That's it. We don't care about these guys. Sorry, no offense. Tenths, hundredths, thousandths, you're good guys, really, and good gals. But you know what? We don't need you because we're dealing with the tens here. All right? So 49 puts me way up here. So obviously we're going to round that number to 50. Now all of you are like going, Mr. Wara, that is so easy. I mean, I can't believe you're even teaching that to us. I'm doing it this way so that way at least you get one more chance to see what's going to happen when we round this to the tenths and to the hundreds. Okay, so that was easy. So let me go ahead and erase this work over here because I want to use my same vertical line. So now we're looking at the tenths. Completely different story here now. All right, now we round to the nearest tenths. Okay, this is what may seem confusing. We're going to have to bring in the tens and ones here at some point. Let me show you why. Because our goal is to round to the nearest tenth, but we want our number to be in standard form. Again, this is standard form, but we wrote 496 tenths, and then we have our 700ths. This is not in standard form. But the reason why this lesson is trying to teach you to put it in the tenths is because you might find it to be easier just to say, well, my minimum and my maximum. Well, my minimum here is 496. Okay, so I could put my 496. Unfortunately, I do have to put my 496 here as the minimum. I'm not going to worry about this hundredth here right now. All right, now I come up here. Well, this is tenths. It's going to round to the next tenth. So it's either going to be 496 or 497. You see? So now we have this, just like we did the last time, is either going to be the minimum, which is 496, or it's going to be rounded at 497. Of course, we're talking about tenths. Okay, and it's the part where it gets confusing because it looks like a whole number. It looks like we're talking about hundreds. And this is why I think this method, I don't know, you may find it beneficial. I'm finding this a little bit confusing. Like I said later in the video, I'm going to teach this the way I would teach it. So here, the midpoint then would be 496.5. We have to show that. Tenths. These are all tenths right now. All right? Even though I know that 5 looks like a tenth. These were all converted into tenths. Now I look at my number again, and I can see that I have 496.7 up here somewhere. So now you can see that we're going to round that number up. And we're going to round it to 497. Now let me show you what we would have to do, though, to get this back in standard form. If you recall, I said we need to multiply, right, in this case, we actually multiplied by 10, right? But now that we're here at this end, what we can do is we can divide by 10. So if we were to divide this number by 10, because it's actually, imaginary, or not imaginary, and invisible, let's say, a decimal point here, now we have 49.7. And that would be that number written as a whole. But this is why I find this kind of confusing, because this is what we really did. And I'm going to show you this algorithm, and then we will go on to it later on in the video. Here we have 49.67. Let's say we're going to round to the nearest tenth. Okay? This is what we all do. When you get into middle school and high school, this is what we're going to do. You're going to look at that number. You have to be able to quickly determine what this rounded value would be to the nearest tenth. Well, we're going to look at that tenths place because it's crucial, just like what we did here. We're going to look at that tenths place, but then we're going to look to that place value to the right. In this case, it's the 7. Now, it's pretty simple. A lot of it have tricky ways to remember, but this is pretty much the rule. Okay? We say that, if the number to the right is 4 or less, that we let this 6 rest. It just means we're going to round to the minimum here. We're not going to round to the maximum. Now you come over here and you look at the 7. Well, that's not 4 or less, but it's actually 5 or more. And we say if it's 5 or more, we up the score. Which means he's just saying that we're going to up that 6 to a 7. Because again, just like with a tenths place, we said, hey, he's at least a 4, he might become a 5. He's at least a 6, he might become a 7. Who decides that? The place value next to him decides that. And the 7 decides that he's going to go up to 49.7. Now, some of you are going to say, Mr. Wara, I don't understand why you just didn't teach it that way the first time. This makes more sense than doing it here in the vertical number line. And I would agree. However, the one thing that I think this lesson is really, really good is that it's getting you to rename units. That's important to be able to see that there are 496 tenths in the number 49.6. It's important that you see the power of 10. That's a Common Core standard, and it's the base 10 system we use. Just phrasing that. Now, we have other problems that we can do. And in this case, maybe we'll do one more here, and then we'll go on to how I'm going to teach it, which is just be similar, but a little bit different. Here I put in my decimal point right away, difference between whole and part, and then I can put in my 9 ones here and my 9 tenths, 4 hundredths, and then 9 thousandths. Now in this case, you can see, and what you guys should be noticing when you see this number above everything else, This is the real math understanding, having a math concept, that this number is almost 10. And that's what you really should see when you look at it because it's so close. You have 9 in the ones place, and look what you have in the tens place. It's a 9. And remember, the rule is we can't put a 10 in one single place, so we have to regroup. That means that if we add one more tenth, this number goes up to 10. All right? And that's something you should start to see. I think that's more important. Now, when you also look at this number, and this would be really important, that you can see that if that is going, so if we rounded this number to the nearest whole number, oh, let me get my yellow. So if I rounded this to the nearest whole number, that means that our answer is going to be 10. All right. If I were to round this number, let's keep going over. If I round this number to the nearest tenths place, you can see we're going to look to that digit to the right. And that 4 is telling them, no, 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 no. You're almost there. Not quite. Then that 4 is going to tell the 9 you're going to stay. So he's just going to be 9.9 to the nearest tenth. Let's just keep going. So if we round this number to the nearest hundredth place, you can see that we have a 4 in the hundredths place, but we have the 9. And 9 is saying, yeah, go for it. You know what? Round to the maximum because I'm 5 or more, so I'm going to up the score. I'm going to make the 4 turn into a 5. So this number would be rounded 9.95 if we rounded to the hundredths place. Now we just rounded 3 places, and we did it not with a number line, but we did it with the understanding that that place value next to the number, the place value that we're rounding, all right? Sorry that I'm using the same words to describe. If we're rounding, if we're looking at the tenths place, we're looking to that place value to the right. So here we have 10 to the nearest whole, 9.9, 9.95. Now something you should notice, what happened to the 4, 9 here? Well, once we round to the nearest whole, all those other digits just turn to 0. The 9.9, look at what happened to the 9. Well, we're not rounding him, so he automatically turns to a 0. So you could write it this way as well. Okay? I hope some of this is kind of making some sense here. Now, again, in this lesson, we're asked to go ahead and rename these into tenths. Well, we know there's 10 tenths in one whole, so that means we would have 90 tenths plus the 9, we have 99 tenths. And we just put these 4 and the 9 here, which again, this is where the part where I see people getting really confused. But we don't have enough hundreds or thousands to make another tenth, so they're just kind of sitting there. So I guess the focus should be is that this one here, depending on what we're going to do, this is what we're looking at. This was rounded, I guess, to the nearest whole here. And or it's not even rounded to the nearest whole, but this is actually our number. So here we have hundreds. We have 100 hundredths in one whole. So we're going to have 900. We have 9 tenths, and that's times 10 because he's 10 times greater. 9. And then we have 4 hundredths. And again, there's the 9 there. So this has been put in units of hundreds and tenths. All right. Now, to go ahead and show this on the number line. We put this on the number line. Well, if we're going to round to the nearest whole, you can see the nearest whole here, he's going to be at least a 9. Correct? That's the minimum. Okay? But he might go up to a 10. All right? Well, that would mean that the midpoint would be 9.5. 9.5, in this case, is going to be the midpoint, so our 9.9 puts us way up here. And again, we already talked about that. Yep, there it is, 10. All right? Now I'm going to erase this. And now if we do the nearest tenths place, well, he's right there. He's at least a 99, and he could go up to 100. All right? In this case means a new whole. But he's got 99. We have 99.5 then is going to be the midpoint. What do we have? 99, and then we have a 4. And this is just like what we were doing before. We're looking to the digit to the right. We're looking to the right to decide where is he. He's right here. Okay? Didn't make it. Okay, he's 4 or less, so we're going to let it rest. But keep in mind, these are in tenths now. These aren't like whole numbers, and this is where I think it could get confusing. This is really rounded to 9 point, let's see, we did that with 9.9. So this here makes it seem really, really confusing. So he's going to stay here. Not 99, but 9.9. Okay, So let me go ahead and go over. So let's go ahead and take. Now this is what I find to be extremely important that you be able to do in math, and it has to do with rounding. So I'm just going to write a number. We'll start off easy and then a little bit more challenging. I will include tenths though, however, in this. So the first thing that I would ask you to do, and that is to simply plot that number on this number line. Now, the reason why this is important is because you need to decide how you're going to show your number line. I mean, you kind of, if I put a zero here, then I need to decide how far am I going to show? What quantities am I going to show on this number line? Now, I could start at zero, but I don't have to. See, this is a number line, and these two arrows on either side let us know that it goes on, pues, to infinity, right? And infinity and miles beyond, or how does it say? Okay, from Buzz Lightyear. I'm sorry, bad impersonation. Anyway, so I could start off at 20. I could start off at 22. It really doesn't matter. I'm just for the sake of doing this. I'm just going to start off at 20. I don't have to. I could start off at 22. So if that's 20, and now I'm going to have to decide how far am I going to go. Well, I have 23.5, so I need to at least have that. So I'm going to go ahead and just go to 24. Again, this number line could be set up any way you want. Now, the nice thing about this is with my 20, 21, 22, 23, we know there's three lines in there. So I can kind of break this up kind of in like in quarters, right? Because there's 20, there's 24. That means 22 is here. Means 21 is here. You see where we're going with this. Now you can see about where our number is going to end up. Now, it's 23.5 and it's a halfway point. Well, I just got to find the halfway point here, and then I can say that this is 23.5. Now, this is how it has to do with rounding, because you might be saying, Mr. Wara, what does this have to do with rounding? Well, if that's my point that I'm plotting on this number line, and notice I did choose a horizontal line. I do like my lines this way, not vertical. So that lets me know that right there, it's right in the middle. Zero point 0.5 is half. So the dot, or this point, this value, is exactly in the middle. It's no closer to 23 than it is to 24. It's right in the middle. But we have this rule in rounding that we say, well, if it's 5 or more, right? If it's 5 or more, it says that we up the score. So that means that we just chose randomly just to say that we're going to round up. We could have decided to round down, but we decided the rule is we're going to round up. So that this number here, rounded to the nearest whole number, okay, is going to be 24. All right. Now I know you're probably saying that's really easy, Mr. Wara. Well, let's just bring on some steam then. All right. So let's challenge you. Let's do 6.074. All right. Now plot that number. All right. A little bit more challenging. We're going to round it, and we're going to round this number so that or say it's to the nearest. Let's just say it's going to be to the nearest hundredth. Okay. And let me write that out here. So, but how are we going to plot it to the nearest hundred? I've got a lot of digits here. Obviously, if I put 0 here and like 7, I'm going to get a lot of little lines in between. So I think what will be significant here, or going to be helpful for us, is this. We have to remember that this number line is going to have to show these decimal places here. So I think it would be wiser just to say, I'm going to say that this is 6 and this is 7. Well, this kind of helps us out here because now we can say that this is 6.5. Great benchmark decimal, just like a benchmark fraction. It's right in the middle. Perfect. Now, if we know that 6.5 is here, the neat thing about it is we can say that 6.75 is here. You're probably thinking, oh yeah, my decimal is going to go right here. But it's not. See, this is the tens place, has a 7. What do we have in the tens place? 0. So really our number is way here on this side because that's half of that. This is still a 0. Now you can see where we can go with this. Let's now rethink our number line. See, now what we can do is, instead of using that 6 to 7, which seems like such a great idea at the time, now we can say, well, you know what? No, I'm going to do this as 6. And then because of our number, because we're going to round this to the nearest hundredth, I'm going to make sure that the area here that I show, that maybe I show all the way up to hundredths. Okay, so maybe this, rather than going to rather than going to 7, so I'm going to go 6.0, and let me just go to maybe 6.1. Now I'm looking at my number completely differently. If I look right in the middle, what number is going to fit in between 6.0 and 6.1? Maybe some of you are thinking 6.05. Right? We have 10 hundredths in 1/10, so the halfway mark is going to be 5 hundredths. Now you can see how this here, how much more challenging this is. It's helping us round the number though. Now we look at the hundredths, we have 6.05. Now you know we're going to have 6.06, right? 6.07, 6.08, 6.09, and then we get our 6.1. Now we have 6.074, almost the halfway point. So this would be, let's call this guy right here 6.075, and ours is right here. So now when we're rounding to the nearest hundredth, you can see that we're not going to go from 6.07 up to 6.08. We're not, because the 4 here is telling us you let it rest. Okay, now the more that we can take numbers like this and divide them in the proper sequential order, like this one here, we could do this with the tenths place, the thousandths place, and still show our number line like this. This to me demonstrates better number sense when it comes to decimals and what's happening with decimals. And I know that we're going to be doing some work like this in the future. Anyway, this concludes this video, my friends. Hope you had a dandy time. Nothing like, number lines and all that kind of good stuff. But now, as you hear that wonderful bumper music in the background, it is time for me to say, live long and prosper.